So the next thing we are looking at is the Fortin barometer. How does a Fortin barometer look like? This is the second type of barometer. The first one we looked at was the mercury barometer. So here we are, the Fortin barometer. What are the main parts of a Fortin barometer? You see, Fortin barometer has a vernier, that is the scale. It has a screw to adjust the vernier. If you want to adjust the scale, there is a screw there. Okay. Then you have the barometer tube, the one which is containing the liquid. Then you have the outer part which is protecting the brass tube. You have mercury inside, as I already said. There is the ivory pointer. You see that sharp part there? It's very important in a Fortin barometer. You have glass. You have the leather bag, the one which is containing the mercury down there. Then you have the screw to adjust the mercury level. If you want to adjust the mercury level, you can use the screw down there. Now we are saying this leather bag is very important. You can adjust it using a screw. The screw which is down there, remember, we have a number of screws. There is this one. This is the one used for adjusting the mercury level in there, and here there's a leather bag. So you can adjust this level of mercury until the mercury touches the ivory pointer. So you can use this screw. You adjust it so that this part either touches the ivory pointer or not. That's why we are saying the leather bag can be adjusted by the screw in accordance to variations in atmospheric pressure. So the way the atmospheric pressure varies, it can enable us adjust the leather bag in accordance with the variation. So the leather bag can be adjusted according to atmospheric pressure of a particular day. It is adjusted so that it just touches the ivory pointer. You see, you adjust it so that it touches the ivory pointer. So this is what we are saying, that when you adjust here, you will adjust it, and as you adjust, this leather bag will be moving up until this part touches the ivory pointer. So you can adjust until, okay, it is adjusted so that it just touches the ivory pointer, which coincides with the 0 mark of the scale before reading. So before you take any readings of atmospheric pressure using this barometer, you first adjust the leather bag using the screw down here, so that you adjust it so that it just touches the ivory pointer. Once it touches the ivory pointer, it means it is now coinciding with the 0 mark. You have set the scale, so you can now take the readings of the atmospheric pressure. So the height supported by atmospheric pressure is then more accurately measured and expressed in terms of the height of mercury. For example, millimeters of mercury, and an example here is 760 millimeters of mercury. So when you are using a Fortin barometer, in brief, what you do, you adjust the leather bag, this one, using the screw. This is screw, you tighten like this, so the leather bag will move up until it touches the ivory pointer here. Once it has touched the ivory pointer, it means it is now matching with the scale which is on the vernier, vernier scale. So then you have already set the scale. Now you can take the reading. You can now take the reading of the atmospheric pressure. So this is how you can use a Fortin barometer. So the third example or type of a barometer is called Aneroid barometer. Now we are beginning by explaining why it is called aneroid. And we are saying it operates without a liquid. This type of barometer does not use a liquid. And for that reason, that is why it is called aneroid, because it does not use any liquid, does not use water, does not use mercury, does not use anything, doesn't use any liquid. So that's why it is called aneroid. The same type of barometer is very important because it is used in a meteorological station, that is a weather station. So we are saying it is also used as a weather glass, you see. So people who always talk about weather, whenever they take readings, when they give us news, there is somebody who always gives us the readings, how the atmospheric pressure is varying, how the temperatures of the day have been, which part of the country has been the hottest, and so on. They do this from the weather station. So an aneroid barometer is used as a weather glass. And according to this barometer, we are saying generally, low atmospheric pressure means unsettled weather. So for them, they detect from the weather station. Once they see that the atmospheric pressure is low, it means the weather is unsettled. And rising atmospheric pressure means fine weather. So when the atmospheric pressure keeps on rising, increasing, it means the weather is fine. So they use this to tell us about weather. They use this barometer. How does this barometer look like? I want you to take a look at this, the diagram. In this diagram, you realize that this barometer has something here. I want you to look at this. This is what we call a metal can, this one. Now, this metal can inside, there should be no air. That's why we are calling it a vacuum. Now, this metal can is connected to a pointer. And this pointer is also connected to the what? The scale. So now, how does this aneroid barometer work? Remember, there is atmospheric pressure pressing this metallic can in all directions, you see? So which means, and inside this metallic can, there is no air. There is no pressure. There is nothing to create pressure inside. So there is no pressure inside. You know, if there was a pressure inside, it would be pushing the metallic can out. It would be balancing with the atmospheric pressure, but there is totally no air. So this pressure outside is more than the pressure inside, because surely inside there is no air, so there is no pressure even. So since there is no pressure inside to balance this one which is outside, this metallic can easily be crushed inwards. So to prevent it being crushed inwards, we use a spring. So this spring is here, a very strong spring holding. So as this one is trying to squeeze the metallic can, the spring is trying to hold it. So this is a control spring. Now I want you to take a look at this. Supposing the weather is fine, so the atmospheric pressure is rising. So once the atmospheric pressure is rising, it means the force which the pressure will squeeze this metallic can inside. And when it squeezes it inside, what happens? This metallic can will be being pressed down. So what happens to the pointer? The pointer moves like this. The pointer will be increasing. So you will be able to read the value of the atmospheric pressure. And once you see the pointer increasing, it means the reading is rising, the atmospheric pressure is increasing, and therefore the weather is fine. What about if the atmospheric pressure is low? It means the force which is squeezing this metallic can will be small. So what happens? The spring will pull the metallic can up, and then this pointer will be moving backwards. And you know, moving backwards means the reading is reducing, because this is the smallest value, this is the highest value. So if this thing is moving down, then it is increasing. If it is going backward, then it is reducing. So in brief, we have a metallic can, this one. This is a metallic can. You can also call it a cylinder. These arrows represent atmospheric pressure. pressing the can in all directions. Inside this can there should be a vacuum, there should be no air inside. Okay, there is a spring here controlling. This is a pointer and this is a scale. So briefly, this is the diagram of aneroid barometer. Now let us now explain further in form of now writing that it uses a metallic can without air inside it, but corrugated. You see, this is a metallic can without air. If there is no air, then it is a what? Inside here is a what? A vacuum. But we are saying the metallic can must be corrugated. You see these things here, these ones. I think if you have seen the iron sheets, they have this kind of thing. That's why sometimes they are called corrugated iron sheets, because they have this. So our metallic can also has this. That's why we are calling it corrugated. So it uses a metallic can without air inside it, but corrugated. Okay? If atmospheric pressure increases, what happens? The metallic can is squeezed, as I explained to you, and it curves inwards. You see, once this metallic can atmospheric pressure is too much, it will press this thing downwards and it will curve inwards. Okay, however, if atmospheric pressure reduces, what happens? The spring pulls up the top of the can and the metallic can curves outwards or expands. You see, when this pressure, when atmospheric pressure is low, it means the squeezing power is low. So what happens? The spring will overpower and pull the thing, it will pull the metallic can upwards. And what happens? The reading reduces, meaning that atmospheric pressure is reducing. So what happens to the cylinder? The cylinder now expands. The cylinder expands. Okay? So these movements of the can are magnified by a system of levers. You see? Those movements of the can, because sometimes the can curves inwards, sometimes it curves outwards, depending on the size of the atmospheric pressure. Those movements of the can, they are magnified by a system of levers. These levers are connected to the pointer, and the pointer is also connected across the scale, as you saw in the diagram there. So as a result, the pointer gives the reading. So whether atmospheric pressure is low or high, the reading can be taken. A strong spring, that is the work of the spring, stops the atmospheric pressure from crushing the can completely. Without that spring, atmospheric pressure would just crush the can. So it is the work of the spring to stop atmospheric pressure from crushing the metallic can. Another thing we need to note is aircraft pilots and mountaineers, they measure their heights above sea level using aneroid barometer as altimeter. So people who climb mountains, who go for mountain climbing, and then those pilots of aeroplanes, when they want to know how high they are from the ground, they use aneroid barometer. So the instrument used for measuring altitude is called altimeter. So for that reason, aneroid barometer, much as it measures atmospheric pressure, it also helps mountain climbers and pilots of aeroplanes to measure their heights above sea level. So for that reason, it is used as an altimeter.